Hi, my name is Michael McNamee. I'm Senior Network Engineer here at Secure Edge Networks. Welcome back for part 2 of our whiteboard series on Wi-Fi calling in your wireless network. Today we're going to be talking about the functions or features that your wireless network are going to have in order to accommodate optimal or high performance Wi-Fi calling. The first feature that I want to talk to you about that is going to be necessary to accommodate Wi-Fi calling on your wireless network is DPI, or deep packet inspection. What deep packet inspection is it's the ability or the function that as the packets come into the wireless LAN system, it identifies it as a voice, a video, or a data packet. And what that does is it allows us the ability to give prioritization to the packet. So in the instance it's a voice call, we can give it the highest level of priority. If it's a video packet, we can give it the next highest or second level of priority, and data would be last or what we call best effort. In this manner, we can ensure that voice as a service is guaranteed to work and works optimally on the wireless network. The next component that's going to be critical to being able to host optimal Wi-Fi calling on a wireless network is WMM, or Wi-Fi multimedia. And what WMM does is it breaks down or gives you 4 categories to identify the traffic and give it some QoS or prioritization. So again, we're seeing voice, video, best effort, and background. And based on the identification of the traffic, we can give percentages to these categories for quality of service or prioritization in the network. So again, we could guarantee or ensure a percentage of bandwidth to voice, another percentage to video, best effort, and then whatever's left over the background gets. And then this is applied to the wireless traffic before it ever hits the wire. Band steering is another component you're going to want to have on your wireless LAN system to accommodate Wi-Fi calling. And band steering works in understanding what your device is capable of. So in the instance of a mobile phone, it's going to see that it's dual band capable. It's going to keep it off the slow 2.4 network and coax it over to the 5 gigahertz frequency for better, faster speeds. Another helpful component that your wireless LAN system should provide to enable optimal Wi-Fi calling experience is a feature called load balancing. And the way load balancing works is it looks at the device capabilities and looks at the APs in the environment and understands the client load. So in this example here, we've got 3 APs in a given space. Unfortunately, all 6 of the clients in that space have decided to connect to a single AP. What the system will do is it will disconnect the client devices and try to distribute them more evenly across the other APs in the space so that frequencies are freed up and processing loads are distributed evenly across the APs. Since Wi-Fi calling clients are mobile, they're not stationary or static, it's going to be important to have a feature like optimized roaming to help the clients maintain consistent call sessions as they roam throughout a campus or even a building. So what optimized roaming does is it's the ability of the system to identify the client connection from the AP to the client and then help it hand off as it moves throughout the facility or the campus to maintain a very consistent call quality throughout the entire session. The last component I want to discuss when we're talking about Wi-Fi calling in your wireless network is an optimal design. Now, optimal design really isn't a function or feature of your wireless LAN system, but I do think it is crucial and critical to facilitating a good Wi-Fi calling client experience. The first component in optimal design is to be able to design for 5 gigahertz coverage. This is going to give you a cleaner spectrum and more channels for the Wi-Fi calling devices to use. The next item is AP power level symmetrical with the client device capability. So mobile phones have a much lower power profile than say a laptop. So you're going to want to design with the AP power level set symmetrical with those mobile phone devices, not a laptop. The third component, a third item, is to design for a specific signal level in a primary and a secondary status. So our primary goal is to deliver neg 67 dB to the primary area that a mobile Wi-Fi calling device would be in, and then a neg 70 dB secondary area that as the device roams away from its primary cell, it's going to be able to roam over to the next AP or the next cell fairly seamlessly. And then the last item, understand that calls are going to happen everywhere. So with that in mind, make sure that you're designing for it. Your end users are going to surprise you with the number of places or the types of places that they're making calls from. Stairwells, maintenance closets, behind buildings, potentially even in the restrooms. Wi-Fi calls are going to happen just about anywhere, so make sure that you design for it. I hope you've enjoyed our whiteboard series on Wi-Fi calling in your network. In the description field below, I've included a link to our wireless LAN design kit. It will provide you everything you need to know before designing or deploying a large-scale wireless LAN. If you have any questions or comments for us, please leave them below. Again, thanks for joining us and hope to see you next time.